Good afternoon, everybody. Let's get this going. Thanks for coming to this. As Southern mentioned, this is going to be a workshop, so not only is it the first session after lunch, so you're all probably a little sleepy, but I'm going to ask you to do some work. So there's a bunch of material on your desks. I will explain what it's necessary for, and if anyone's missing anything, we have extras. To quickly introduce myself, my name's Mac. I work at Domino, and I work with some of our largest customers to understand how their data science process works and help go through an exercise, which we do, and that we're gonna do together with you at the back half of this session. I also used to do this job myself. I worked at Bridgewater Associates along with Nick and Chris, our co-founders, where I was building quantitative models for investments. And so I've both been in both work with smart people like you guys and also have done the job myself. I also have a group of TAs there's a bunch of Domino people over here. When we get into the interactive portion of this, they're gonna be wandering around. If you have any questions or if you get lost, feel free to flag any of them down. This is supposed to be, there's a lot of guidance to this. It's a fairly prescriptive exercise, but if you ever have a question, feel free to grab them or come ask me. Here's how we're gonna spend the next 90 minutes together. And so at the beginning, I'm gonna talk a little bit about data science as an organizational capability. That's a theme that you're gonna hear a lot about at Rev. We've already heard a lot about it this morning from our keynotes. Then I'm gonna go 20 minutes into some best practices for the data science lifecycle. You all have an extremely intimidating flowchart in front of you, and I'm gonna talk you through it and sort of make it a little bit more accessible. Then my colleague Phil is gonna join me on stage and talk you through an example of how we've done this with some of our customers. And then we're gonna turn the tables. It's gonna be your turn. And so for 40 minutes, you guys are gonna work through 2 exercises about how your data science lifecycle works today and some of the challenges you face. So it's collaborative. As we get to it, I may ask you guys to stand up, stretch a little bit because I want everyone, this is a high energy thing. And then we'll come all back together for a quick close. So that's where we're going. When we talk about data science at Domino, we talk about building an organizational capability. That is more than just a narrow technical skill. It is something, it's like sales, it's like marketing. It's a capability that organizations have built and is resilient to any one person quitting and allows them to scale. And when we think about doing this, we think about people, process, and technology. And it is beyond the scope of a 90-minute session for us to talk about all this in detail. There are some awesome sessions coming up, which will touch on some of this around the people and the technology. I'm gonna focus on the process today. So I'll talk briefly about people and technology, but know that there's a lot of other smart people here at Rev who can help guide you on that journey. On the people side, a few things to quickly say. People is a theme that comes up all the time when we talk to data science leaders. I can't hire enough people. The people I hire quit really quickly. There's data that suggests the median tenure of a data scientist is less than 2 years, and it often takes them 3 months to get ramped up. So it's an expensive proposition managing a data science team. And not only that, there's a lot of new people calling themselves data scientists. And so a lot of data science leaders have told us they are overwhelmed by resumes, but underwhelmed by the output. And so there's a lot of expertise and a lot of tips and tricks. I highly recommend joining the panel at 3:45 today, where some of the data science leaders are gonna talk firsthand about their experience and you can ask questions. On the technology side, obviously at Domino we build a software product. It's a technology platform for data science, so we have a little bit of an opinion on this. I'm not gonna talk about Domino, that's not the point of this session. What I would say is that the key that we've seen for successful organizations is they view technology as a means to an end, not as an end in and of itself. And the 3 things that you should try to enable with technology are collaboration, because most people who we talk to and studies that we've seen and conducted ourselves suggest that collaboration is one of the most important factors for predicting data science success. Reproducibility and reusability. What Jacob talked about this morning in terms of auditability is critical. Not all of you are necessarily in a regulated industry, but that doesn't mean that you should not think about transparency and auditability. That art slide really resonated with a lot of us. And then agility and flexibility. There is no one tool that is going to solve this for you. You can't build an organizational capability on the back of one tool. And the data science ecosystem is evolving so fast that it's critical to be able to use all the different tools that are coming out. Something great might be open source next week, and you don't want to be locked out of that. But today, we talk about process. And process is not just flowcharts. There's a daunting flowchart in front of you, but we think about process as the machine by which you generate output. It's not just one model, it's how does this thing build, how do you build a repeatable process? And we like to say that there's more to data science than just data scientists. There's a lot of people involved in this. If you guys look at that diagram that's in front of you, you'll see a lot of little dots in the corner of each box. And those dots represent the different stakeholders who are involved at every step along the way. Moreover, as you look at that diagram, you're gonna realize, hey, my diagram doesn't look like this. This is not exactly how my life cycle goes. And that's okay, because a lot of companies have different ways of doing this. However, the most important thing we've seen is that actually going through the process of writing it down is surprisingly effective. And so that's what we're gonna do in the second half of this exercise today. I wanna spend a little bit of time talking through each stage. As you look at the diagram, there's some vertical sections. I wanna talk through from ideation to monitoring what we mean, some of the problems that we've seen, and some of the best practices that we've heard from leading data science teams. That way, when we all turn and we're working together with our tables, we all have a shared language that we can use, and that will help us have a much more fruitful discussion. So the first is ideation. Data science teams often sort of do this implicitly. One large manufacturing company that we spoke to had hired 30 PhDs. I asked them what their mandate was, and they said, we're looking at the data. We're looking for something interesting. And I was like, oh my gosh, you've got it backwards. In many ways, most leading data science teams recognize that it really is about the problem first. What are you tackling? And also, how big of a problem is this? All of this work is happening before you write a line of code. And so some of the great data science teams we've seen have practices of estimating the ROI of a project up front. And it doesn't have to be exact. This is probably an analytically rigorous crowd here, but I like to think of this as back of the envelope math. If we solve our churn problem, is it $100,000 of gain, $1 million of gain, $1 billion of gain? People often overlook that and just want to work on the interesting problem without necessarily thinking about the business implication. That also goes for the cost side as well. Is this going to take me a day, a week, a month, a quarter? It doesn't have to be exact, but going through that process in advance helps mitigate the risk of a project going off the rails. Chances are teams have built on something that you've already done. And so somebody else in your organization has worked on churn. Somebody else has looked at fraud. It's important to be able to find that work and understand it. Because otherwise, if you have a culture of, oh, it wasn't built by me, or I can't find it, use it, everyone's reinventing the wheel. And the last thing I would say is product managers built this idea of a product requirements document a long time ago. And I think even though models are a little bit different, there's a thing we can learn from that in terms of creating model requirements documents. It doesn't have to be onerous. It doesn't have to be this 50-page PDF. But going through the process of who's going to use it, what are some of the risks, that discipline is a thing that we've seen really work really well at large companies. You may not actually notice this as a large box on your diagram, but it's such an important step I wanted to call out. This is what we think of as artifact selection. There was a question earlier about model design and why it happens before data. And we talked about that a little bit, Jacob mentioned it. But what we have seen with some data science organizations is that if you build a thing without considering how it's actually going to get used and how your stakeholders work, there's a really big risk that it ends up being shelfware. And so some of the leading data science teams do things like rapid prototyping. They're borrowing from the design sprint methodology that has been popularized in software development. Some data science teams even have designers that work on the team that will create mocks of the Shiny app or mocks of things that the stakeholders can engage with. And they can even do this with fake data or a simple baseline model, just to understand, hey, if I gave you this thing, how would you use it? Because that way, it often surfaces a new insight of, oh, well, it turns out that if we put this in a new tab, no one's actually going to go to this different application. We have to integrate it into their Salesforce workflow or something like that. Then there's the data acquisition piece of this. And I have a dirty little secret to tell all of you. which is your data is never going to be perfect, and you should probably stop blaming the data engineers. Because ultimately, that's often an excuse that prevents people from delivering value. And so the way that we've seen this go well is don't try and do something fancy. Don't try and buy some fancy external data set before you've exhausted some of the things that you have internally. And once you do move on to doing something, buying data or instrumenting new data, think about building a process. How do you work with your engineers to build new logging into your app? How do you work with the legal team to make sure that when you buy a new data source that it works with your compliance rules? Those things, if you try and just do it one-off, it ends up taking forever. And the leading organizations will actually have a playbook to do this well. Moreover, think about features as the unit that you're sharing. It's not just a column in a database, but it's actually features that are the things that are most often shared. And so how do you make it so that you can share those and that those are reusable and discoverable? When you get into the sort of meat of the data science process, this is what we call research and development. It's called data science for a reason. And so oftentimes this is where people are exploring data. They are testing hyperparameters. They're trying different algorithm types. And so some of the things that we've seen people go wrong is data scientists spend too much time trying to manage the infrastructure as they swap in and out. And so one time I want to use R, another person wants to use Python. It's too hard for those people to work together. And oftentimes they are just spend a lot of time trying to manage that sort of constantly evolving stack. So give people some standardization, but for the power users, give them the ability to have flexibility to try new and different packages. Another thing that we've seen is that data science teams try and build potentially complicated models first. One company that we worked with built a 500 feature model. It was deep learning. They're really proud of it. They spent 4 months on it. They went to the IT team to deploy it, and they're like, listen guys, half of these features are backfilled on a monthly basis, and you wanted to use this in real time. We can't do this at all. And so they had to go completely back to the drawing board. And they ended up just building a 5-feature model, which they then quickly deployed and started iterating on. And so this is much more about laps around the track than it is about an individual moonshot. And then think about delivering your insights along the way. Data science teams, and particularly junior data scientists, will go into a hole for 3 weeks trying to over-optimize an algorithm. And if they aren't able to quickly and sort of consistently deliver incremental insights or intermediate deliverables, chances are they're not on the right path. And so some of the leading teams that we work with actually require teams to have every 3 to 5 days share short technical memo so that they know what people are doing. And last, think about the KPIs that you're tracking. Your model is not good. I think Kathy talked about this morning, like what defines a good algorithm or good model. And I would also say it's not just about a narrow statistical store or some objective function. It's about the business KPI you're charged with tracking. If it's fraud, like how much do you decrease fraud? If it's new business or conversion rate, how are you affecting that? Because once you're able to share that with your stakeholders, you'll have a much deeper collaboration and a lot more political capital to work with them. Validation, Jacob talked on this, and Jacob is a much deeper expert on this than I ever could be, so I'm not going to go into it in too much detail. But what you think about here is how can somebody make sure that the way you built your model and the way that it's working is robust. The chart on the right, this sort of chain of dependencies, I borrowed this from one of our leading customers, and they think about this. All of these things are a dependency to be able to reproduce a result and to think about fully validating it. And if your validation team ends up spending 90% of their time just trying to get the environment right, chances are they're not actually doing their job of asking the hard question of saying, oh, well, is your model robust to this? Doing the sensitivity analysis. Then think about what pieces of this can be automated. Data science is a little bit different insofar as you can't just do unit testing like you could with traditional software development, but that doesn't mean you can't automate some things. And so think about the different steps, whether it's a certain test, a sensitivity testing, or a back test that could be automated. Last, think about preserving your nulls. Data science will go through a project. A data science team can legitimately work on something for 4 weeks and find out, oh, the model had no lift. And so too often that result just ends up getting tossed in the trash can, and then somebody else will go and explore it 3 months later and not know about it. So it's a little bit like science. We need to make sure that the academic communities preserve the publication of null results. We have to do the same thing within companies. Delivery is about how you deploy a model and actually start affecting the business. And so a lot of times data science teams only have one door. They think the only way I deploy models is recoded into Java. And as a result, you have a lot of things that are trying to cram through a very small door. So think about the right way for your data science product to be consumed by your business. Sometimes it's a person, and they just need to be informed about a decision, and something needs to land in their inbox once a week. Sometimes they want to be able to interact with it, so you need to build a web app. Other times, it's a system that needs to integrate it. It's Salesforce, it's your web app, and those things need real-time APIs. So think about that before you get deep into the modeling process. That's the thing that you should probably have as part of your model requirements document. And then think about a promote to production workflow. A lot of times data science, it takes so long, it's so rare to actually get a thing into production that they don't actually know what to do when they get there. Like, who actually has to sign off on this? What is the approval process? And so if you have a process of that, and there's a rigorous promote to production process, it ensures that IT is bought in, it ensures that the business has faith and trust in what you're building. Monitoring is a step that is often forgotten, and that's unfortunate, because monitoring is where a model is driving the most value or potentially doing the most damage. Models drift. They drift, as Jacob said, the second your model is done is the best it's ever gonna be. And so you need to be able to keep track of that, but you also wanna know, how is it driving value? Some of the organizations that we've seen do this well have a rigorous culture of testing. One large bank that we spoke to, they had hundreds of models, price elasticity models, next best offer models, and they had a universal holdout group that they had cultivated for years. And they didn't get any of the models, they just got the business as usual treatment. And then after every year, they'd say, how much more money did we make on the group with the models for the group with no models? It was more than $1 billion. And as a result, they were able to take that number as justification to double the size of the data science team. And then think about integrating monitoring into where people spend their time. So some of the teams that we've seen, if a model fails silently, that does nobody any good. And so what if you send the alert into Slack so that somebody can see that and engage and acknowledge? So those are the types of things that we've seen as ways to keep track of not just statistical performance, but system performance, because a model is at its most dangerous, but also its most powerful in this moment of monitoring. Not every problem and not every best practice we've seen fits nicely into one of those little vertical panels on your diagram in front of you. And so there's a few things I think that cut across all of this that I wanted to touch on. First is the idea that this doesn't progress nicely left to right. You've all been there, you've all been in this. You get further into the process, you discover that you didn't actually even know how the data was collected, or you didn't know what those nulls meant, and you have to go all the way back. Maybe you even have to go rescope the project entirely. And it's essential that you teach your business stakeholders that that's how this works. It doesn't just work like we start on the path, it's gonna be done in 2 weeks. The thing you do wanna focus on is this idea of compounding collaboration. So what are you doing and what are you building that somebody else could use? Too often data science teams are doing rework. They're reinventing things that somebody else already did. There's nothing more frustrating than finding out that you just spent 2 weeks on something somebody built 2 months ago. Think about reducing that iteration cycle time. And auditability and transparency. I mentioned it once, I'll mention it again because it's that important. You might not be regulated, that's okay, but don't think that that means that you shouldn't do this. And the last point is measure everything. I've seen data science teams be furious at an engineering team or a product team for forgetting to put logging into something, but they don't actually turn that obsession with measurement on themselves. How do we work? Where do we spend all of our time? If you start thinking about that and saying, what if we tried to understand our own process, then you can think about starting to optimize it and make it better. So turn that sort of obsession with measurement inward. So what I've just described is the sort of basis on which of an exercise that we like to call a lifecycle assessment. And so what I mean by that is a process by which we work with our customers to understand how this process, how they build a model, and some of the problems they face along the way. The reason people find this valuable, and I think honestly part of the reason a lot of people came to Rev, is because right now you are not at your desks. You have a moment to step back and have a view on how do I work? How should my team work? You can see the forest for the trees right now, and that's a rare opportunity, and I hope that this session gives you that chance. And I want your thinking not just to be on the tools and the techniques. You'll notice at the bottom there's a bunch of tools listed. There's a lot of tools in the data science process. No one tool is going to solve it. Feel free to keep, as you go through the exercise, feel free to keep track of the tools you use, but remember, it's not just about the tools. Think about the people you work with as well. There's a need for empathy. One data science team came up to me and was like, yeah, we completely underestimated how important political capital was. Now that we actually have some, we see, but for a year, we were completely ignorant about it, and now we understand that it's critical. So think about the people and the different touch points you have throughout your process. Who do you depend on, and how do they and who depends on you? As I said, those little dots in the corner are a guide. You probably have a different way of working, but that's okay. But think about who you need to generate empathy and build that political capital. And lastly, one of my favorite quotes, Peter Drucker, if you can't measure it, you can't improve it. So writing it down is the first step. If you don't actually know what the machine looks like, you can't tune the machine. So with that, I'm going to turn over to my colleague Phil, who's going to walk you briefly through an example of this exercise, and then we're going to turn and go back, and I will guide you guys through the interactive portion of this. You're going to use some of the material in front of you, but what Phil's going to talk you through right now is just a sample of how this works. So you don't need to applause, but here's Phil.
Thanks. Thanks, Mac. Yeah, guys, so I'm going to walk through an exercise, or actually a life cycle that I did for one of our customers recently. So let me just get through that. And just for the sake of secrecy, we'll call it Acne Company. Acme is a regional financial services company. They've been trying to grow their international footprint. As a result of that, they realized they needed a centralized model development system. So they needed to make sure that they could actually do it in a way that's transparent across the organization, specifically because they also needed to adopt some new regulatory risk and security approvals. So in order to build this for Acme, we went ahead and actually created a number of sessions with the data scientists, data engineers, IT, product management, so that we could actually fully understand what people were doing in their individual roles. We asked questions about the process, the people, the tools, and the end of this was creating a visual diagram, much like what you guys are looking at in front of you, but very customized to Acme's actual workflow. By doing that, we were also able to identify a lot of the challenges that people were having. So what are the pain points that people were experiencing when they were building models? Was data a big problem for them? Was it actually the tools? All these sort of things come up as you start asking these questions with people. And we were also able to identify specifically which of the stages that they were encountering those challenges were in. Finally, what we did is we overlaid those challenges on top of the diagram that you guys have, and we were able to essentially come back with something that showed to people what are the bottlenecks that are causing the organization not to be able to become model-driven. Now, in regarding to the last point, and Mac is going to cover this in more detail, we also went ahead and quantified what that means from an actual financial impact perspective. So how many projects are coming down the pipe? Those sort of questions and what those projects actually mean in terms of financial numbers. Mac is going to cover a little bit more about that later. It's kind of out of the scope of what I'm going to cover in a sec. So this is more or less what you guys have. There's obviously a lot more customized to their particular workflow. There are things like that we discovered, things like, for example, the overuse of different knowledge repositories. So they started using things like a blog. Some people were documenting this stuff in Jira. Some people were documenting this stuff in in Confluence, and some people were documenting in some random blog that somebody created. And these are the sort of things that started to make sure that a lot of the knowledge in the organization was just kind of getting lost. We also identified that things like their validation process was overly complex, and they didn't have really a lot of ways to deliver the models and the results that they wanted. So the delivery stage was lacking a lot of options for these people. Coming back to identifying the actual challenges of the gaps that we saw, deployment became one of the biggest things that we, as an organization, noticed was a factor for them being able to become scalable. And the biggest problem with that is that when Acme was handing over their models to go into production mode, there was a lot of teams that were there to be able to manage that process. That translation of model to actual code was not being done in the right way. And it was very difficult for folks to just be able to come in and say, I have a model and let's put it into an API. On top of that, because of that multi-team approach and the fact that everything had to be recoded, the whole process became very cost prohibitive. And it was very difficult for people to come in and actually re-update those models, because every single time those models needed to be updated again, they essentially required a whole new deployment project. So it was very expensive. We also found that there was a particular challenge around access to data, software, and infrastructure. Now, Mac has talked about this. I think everybody here knows access to data is complicated. People don't know where the data sits, what are the true sources of data. How do I access that data? Is there a knowledge owner? These are things that are very common in organizations. We hear it all the time. We heard it here as well. We also saw that there was a problem around getting access to the necessary packages to be able to do the work. So Acme, like many financial companies, and I used to work in a financial company before, so I'm very familiar with this, are not allowed to go out to the internet to get the packages they need. It's very complex to install the new version of TensorFlow or whatever it is that you want to use. And so what some people ended up doing at Acme is actually copying repositories like CRAN internally, but then never actually updating those repositories. So people were going to these repositories and then trying to install the latest packages. It was missing other dependencies, and it was a whole mess. So people were getting frustrated around that. And the last thing, which is also something that we see all the time, is the fact that people didn't have the necessary tools to do the kind of work that they want to do with the data sizes that they want to actually examine. So people were limited by the fact that centralized machines just didn't really exist. Nobody was managing those. And people started going back to using their laptops. And so by using their laptops, they were having all sorts of issues around, I can't handle larger data sets, I can't use newer techniques, and many times they just abandoned these projects. Oh, okay. And the last challenge we saw here, and there were many more, but these are just the three main challenges, was around reproducibility and collaboration. And one of the things, and again, coming back to the point that people were actually using outside repositories for data knowledge or documentation, the fact of the matter is none of those repositories were actually capturing the full component of what it takes to reproduce work in the life cycle of data science. And so when somebody wanted to go in and actually load up an experiment that had been done and see what package was used, what the iteration was, all these different things, none of that was there. A lot of it was just basically, here are the results, here is the code, and go figure it out. And so that makes it very difficult to reproduce the work, especially when we think about a regulated industry like where Acme sits. Finally, the other problem was also around, which is related to this, was also around approvals of models. And the fact of the matter is the validation teams didn't have the necessary context of what was done in many cases. And so they had to either rely on a lot of conversations, but that were completely disconnected from the actual code. And we're relying on people to come back to them with what they actually needed. So this whole process just added a ton of time to the actual process of deploying the model. So coming back to my other point about how we built this, or I guess step number 2, is what we did next is take those challenges and actually put them against the diagram that we customized. And we identified the particular points where bottlenecks were being caused, essentially causing that deployment from ideation to delivery to be 16 months. And now, when we first sat with Acme, Acme clearly said that one of the biggest problems they had is the fact that 16 months is not going to cut it if they want to deliver a number of projects that they have to deliver by the end of the year. They needed to have that be basically about half of that. And so just by understanding where some of these bottlenecks were, we're able to go back and sit down with the management of Acme and say, hey guys, if you do some of these things, if you think about maybe changing some of these processes, and coming back to what we're talking about here today, you may actually be able to lower this down to the time frame that you're actually looking for. So with that, I'll hand it back to Mac. He's going to cover a couple more things in here.
What we're going to do is we are going to do, there's 2 exercises, but there's a step 0. And the first step of all of this is you're going to be working with the people at your table. So what I would like you to do is look around. First off, if you're at a table with only people who you work with, then mix it up a little bit, because part of the value of this is learning from the people who are in other industries or in different places. So, and once you've done that, introduce yourself. Say, you're about to spend the next 25 to 35 minutes learning from the person. So introduce yourself. What's your name? What company you from? What's your role? And why did you come here? Because once you've done that, it'll be sort of 3 minutes. Then we're going to dive into the actual exercises. And as you go through, please grab some of the materials in front of you. There's a set of handouts and a diagram. So I'm going to give you guys 3 minutes. Stand up. It's after lunch, so everyone could use some blood flow. And then I'll call everyone back. And introduce yourselves. So exercise 1 is around mapping your life cycle. So what you want to do here is I just talked through a diagram and I talked through some stages. And if you flip in through your diagram into your handouts, I believe it's the 3rd page, is going to have this page but blank. And so, but blank on the right. So the goal of this is to spend the first 3 to 5 minutes jotting down the notes about how your life cycle works today and why it's any different. Like, what are the things? Maybe you don't have a monitoring program, or maybe you have a totally different way of doing monitoring. Just jot down some of the things that were highlights and differences. And the way that we've found this is most effective is think about 2 or 3 projects you've literally done in the last quarter and think, where did the idea come from? Which person asked for it? What did we check? How did we build it? Where did we deploy it? Who kept track of it? Sort of think through that process and then jot it down. And then the other piece, the bottom box here, is who should you talk to when you go back on Monday morning or Friday, if you guys are responsible and going back to work on Friday? Who do you want to talk to understand this? Because what we've learned, there is no one in an organization who has this whole picture. And so you need to figure out, who do you want to talk to? Do I want to talk to the data engineers? Do I want to talk to the head of marketing who consumes a lot of the data science output? Who are the people? Write their literal names down if you can, and that will help you actually make this an effective exercise when you go back. So take 3 to 5 minutes by yourselves, and then we're going to take 10 minutes to discuss in the table, like, what are the key differences that you've seen? And then after this, the second part of this is talking about the challenges. So keep that in the back of your mind. I'll come back in about 12 to 15 minutes. And again, we have the Domino TAs over here who are going to be circulating. If you have a question, if you get lost, you just have nothing to talk about, flag one of them down. My guess is that there's probably lots to go through, though. So we'll come back in 12 to 15. Thank you. 3 might actually be the most important one. And I'm sorry to say that we didn't actually do the most important one. But the reason is it's hard and it's out of scope of what we could do today. But everything we just talked about is very inwardly focused. It's about the data scientist's day-to-day reality. What is it like in the trenches? Hacking away, trying to get the packages you need, testing out your hyperparameters. And if you go and try and make that case to your CFO, you're like, it takes me 4 weeks to get a Python package. That person is not going to care that much. And so what you need to do is you need to start framing it in terms of the business value at stake. We always talk about the challenge is connecting day-to-day reality to the strategic business value that really is impacted by data science. And so to do that, let me just sort of give a quick understanding of how we did this with Acme. And so the way we thought about it was, how many of the projects that you're doing are affected by this, and how many projects do you do, period? So in Acme's case, every project went through this same life cycle. They had 60 projects that they were trying to do in the next, this year and next year. And they actually had a pretty robust system of testing and value estimation. and they estimated that they had $400 million of business value between customer analytics models, fraud models, that they could be delivering. And that the cost of doing that with data science headcount, compute resources, everything, was around 200 million. They then thought about how much impact can I actually have? You guys all went through, hopefully you drew some X's, hopefully you talked about some problems. You're not gonna solve all of them, but how much could you realistically change? Could you improve it by 30%? Could you improve it by 50%? Acme estimated they had 50% upside and that they could cut costs by 50%. And what that meant to them is that they could go from doing 60 projects, that they could do another 30 projects on top of that, and that they could save money on all of those existing projects. And if you sum that all up, that was about $600 million of value at stake for them. That's a big number. And it's not exact, but that's not the point. It's not meant to be exact, but it's meant to be a back-of-the-envelope calculation that's more than just what the data scientist productivity gain is going to be, but who depends on you? What organizations, which business units are hungry for your output, and what could they do if you did so much more for them? And so this is a hard thing. These are some of the questions in the framework that we've found helpful, but again, I think it's start this conversation amongst yourselves and start this conversation internally, because when you go to try and double your team next year, someone might ask the question, why? What value have you driven, and what value is this gonna do for me? And you wanna have this in your back pocket for that conversation. So, in conclusion, that flowchart in front of you is a little overwhelming. And we've talked a lot about things that can sometimes sound a little bureaucratic, but don't be overwhelmed into inaction. Building an organizational capability in data science takes time. There's not a silver bullet tool. You can't hire one magical project manager who's gonna make this all happen. The first step is writing it down. And hopefully what you started today is writing the first process of this. As I said, hopefully you wrote down some names of the people that you can go talk to on Friday, more likely Monday, the people who can help you flesh this out. You don't have to make the same fancy flowchart that we did, but starting to think about how you work and how you want to work is critical. Another thing that came up, a few people were talking about this, is that I'm not actually sure what we should do. And that's not unusual because this is a pretty new field. The best practices are still being written in this field, and that's why we are here. That's why we wanted to do Rev, is because data science leaders at companies like yours are the ones writing that book, and so learn from each other. Hopefully this session was helpful for you guys, and hopefully that we can help sort of create the standards and the best practices that are gonna carry the whole industry forward. Think about those X's and the things that you can fix in business terms. As I said, this is hard. It's easy to say that we can save 15% of a data scientist's time. It's hard to say that once we can update our fraud models every month instead of every quarter, that we'll save $200 million. That is a harder process, a harder thing to answer, but if you can go through that exercise, it's extremely valuable. And last, let us know if we can help. This is a thing that we've done with, as I said, this is an exercise extremely condensed that we've done with a number of our customers, dozens, and we find it really valuable, they find it valuable, and so we're happy to talk you through some of the things that we've learned. And with that, we've got about 6 minutes left. I want to turn to questions, things, if anyone wants to share anything they learned, raise your hand, we've got a few mics, and yeah, thank you. I see a question back there in the middle.
Hi, I'm a data science manager. I've been a practicing data scientist for 5 years, and I manage a team.
Cool.
I guess one of the things I'm grappling with is production. I've had a lot of success building good data science models and things that work. Just how do you sustain them? Who does the QA? Those are some of the things that are coming to mind.
When you say sustain them, do you mean like retrain them and update them?
Yeah, productionalization. We want to revisit this particular solution. Who writes the unit tests? Is it my junior data scientist? Do I go external? I'm trying to figure all these things, trying to piece this together, because in my 5 years practicing, I haven't worked at a company where they figured it out.
Fair enough. As I said, the best practices are still being written. There's a lot there, and so realistically, I don't think I can answer all of it. And a lot of people here probably have ideas, so if you have a great answer, either feel free to raise your hand or grab a conversation afterwards. A few quick thoughts. Some of the things we've seen is when you talk about deployment, operationalization is sort of a catch-all word, but as I said, there's a lot of different doors into production, and production can even mean just affecting a business process. So sometimes it's just a web app that somebody needs, that's a prototype that people are going to come interact with. That requires a very different QA process and a different degree of validation and rigor than the real-time scoring engine, which is going to power the recommendations that drive 40% of your revenue. So don't assume it's a one-size-fits-all. And then I think the other piece of this is changing the mindset around the downstream consumers, whether that's the people or the application developers and systems owners who you're trying to integrate with. A lot of times people think about this as just a traditional software development process, and so there's a little bit of subtlety there, and people need to think about not just deploying it and sort of throwing it over the fence to IT, but how can we make sure that our data science team can keep it updated? Because models are always going to drift, and if you only update it once every 3 years or once somebody notices something's gone wrong, then you're going to undermine the credibility of the data science team, and it's going to make it all the harder to do it the next time. Any other questions? The question was, how does the data science platform sort of interweave into this? Obviously, we have an opinion on that as Domino. What I would say is, sorry. I promise I didn't see that. No, but realistically, technology has a role to play in a lot of this, but I like to, especially in, I think, the middle part of that experimentation process and being able to share intermediate insights and making sure people have access to the tools and technologies they need. There is still a human element to this and a process element to changing mindsets. You can have the best data science platform in the world, but if people don't think about, I finish a project, I need to archive it, I need to document it. Software developers, probably through decades of being sort of beaten into submission, have learned this idea around documentation, and it's much better than it has been in the data science community. I think we're still going through that, and so a lot of it is changing the mindset, but a platform, I think, can also make this a lot easier. One of the things we often hear about is, should I have a centralized team or should I have a decentralized team? What we've often seen is that some of the challenges of being close to the business are better solved with a decentralized team, but then often some of the challenges of knowledge management and enforcing standards and best practices are really good in a centralized team. And I do think that a data science platform can be really helpful of giving you that benefit of decentralization, which is, makes sure a data scientist is intimate with the problems of their stakeholders, while also giving them a community and a place to draw on the infrastructure and knowledge they need to do their job well. All right, we got about 1 minute and 30 seconds. Any other questions?
My name is Derek. I work as a data science manager at a company called Lending Home. One of the problems that we've run into is knowing when to actually use models as opposed to defer to people to make estimates. And so I'm curious whether or not you have worked with any clients that have tried to generate an estimate of like model confidence in addition to an actual output for that model, and how they implemented that process to know when to defer to a human.
It's a good question. It sort of gets to the interpretability question that came up with Jacob. I think different use cases require different levels. So things like a lending decision, especially when you have human underwriters, it's really important to be able to give people transparency and understanding into how a model works. What we've seen is that a lot of data science teams now don't just ship a model, but they ship an explainer too, like an explainer app or something like that, that helps give the stakeholders an understanding. And the other way that I've seen this go really well is don't just bring the stakeholders in at the end and say, oh, here's your model, like, I'm gone now. But bring them in from the beginning. Someone who knows that workflow really well should be part of the process. They're the ones suggesting which features you should use. Because once you've sort of built that understanding, they feel more invested in the model, and the model is almost certainly going to be better off. And so that change management and that confidence in what you build is more likely to be sort of a lot easier and lead to much better adoption and continued encouragement from the stakeholders. All right, and that gives us time. So thank you all. I hope you found this a valuable exercise. Again, find any of the TAs, find me if you have any other questions. And thank you for actually doing work after lunch. We really appreciate it.